Today we're going to continue looking at solids of revolution. We've got all of our slicing strategies. The two big categories of slicing strategy are slice perpendicular or slice parallel. Once we decide on a strategy, once we've identified a region and an axis, and we decide on a strategy, that tells us what our volume formula is going to look like and how we should go about labeling things in our diagram. So this is taking the slice and the axis out of any extra noise, out of the actual region, and just looking at what we're trying to install when we're deciding on a strategy. So here's how we can practice. So each time we define a region, we'll have 4 to 6 places. Well, actually, there's way more than that. But what we're going to think about is 4 to 6 places to put an axis, 2 slicing strategies, or 8 to 12 problems per region, just by taking one region, rotating it about a bunch of axes. So for any given region, I picked a region with a horizontal and a vertical boundary. So let's suppose these are the boundaries of the region. Let's think about all the places we could put an axis of rotation. This one, we can have an axis of rotation, a vertical axis of rotation on that vertical boundary. We could put a vertical axis of rotation to the left of the region, or a vertical axis of rotation to the right of the region. I guess if we had another vertical boundary, then we could also put an axis there. But really, I just need boundary, left and right. We could put a boundary on the horizontal, an axis along the horizontal boundary of the region. We can also rotate around an axis below the region. We could rotate around an axis that's above the region. So if I have an axis over here that's to the right of the region, vertical axis to the right of the region, it doesn't really matter how far it is from the right of the region. This axis is not a boundary and it's on the right. So we have to make our decisions based on that. Once we have a region, we have to decide on what slice we're going to use. We can either slice parallel or perpendicular, but the slices are always going to be drawn not with regard to where the axes are, but inside the region. So you always jump into your region and draw where your slice is. Here's a slice that we could draw if we're going to slice perpendicular. We have decided to slice perpendicular to one of these vertical axes. Or maybe that's the slice that we draw because we decided to slice parallel to one of those horizontal axes. Or I could draw a vertical slice in the region. And that would be a slice that is, a slice that is perpendicular to these horizontal axes of rotation or parallel to some vertical axis of rotation. Questions? So there's how we're going to label things relative between the axis and the slice. There's how we're going to label things inside the region. That's where we're going to put the slice in the region. Then if, for example, we have the delta X slice and this bottom axis down here, I'm going to have a radius from the axis to the to the near end of the slice and a radius from the axis to the far end of the slice. So if we define one region, we can make at least 4 problems out of it. Axis above, axis below, axis to the left, axis to the right. If we have a boundary that's horizontal or vertical, then we would also want to practice with an axis there. Any questions? Is everybody okay? All right, so let's do our, I'm not going to fit it there. So I'm going to grab the same region that we had before, the region bounded by y equals x squared, y equals 9, and the y-axis. So here's our region. We've used this one before. Let's pick an axis and write an integral for a horizontal slice and a vertical slice. So we've done the axis with around the y-axis with both slices. Let's try another vertical axis. Let's put that vertical axis just over here at x equals -2. Let's put that at -2. So let's draw a slice perpendicular to the axis. That's a choice that we're going to make. We decided I like perpendicular to the axis in honor of, oh, I guess they both, well, they're both going to have pi, so never mind. Let's draw a slice perpendicular. Once we do that, our axis is vertical, our slice goes horizontal. Notice I drew the slice in the region. So that's the choice we had to make there. And since we have an x equals 2 axis, our delta variable is going to be delta y. The fixed parts of the problem were region and axis. Slicing perpendicular with delta y is a choice that we made. Once we make that choice, that tells us that we have decided to use the volume of the slice is pi times r squared minus r squared times the height. The height in this case is going to be the delta variable, so I need 2r. One radius is from the axis of rotation to the near end of the slice. And the other r is from the axis of rotation to the far end of the slice. I'm gonna have to write each of those r in terms of x and y. Right now, I'm looking at my diagram. I don't know where x and y are. I need to label where x and y are. So I pick a point on the curve y equals x squared. And now I have labeled where x is and where y is. Radius, anything called a radius is always measured from the axis of rotation. X and y are always measured from the origin. Now we can see how all these things are related. Questions on the sequence of events? You were given a region and an axis, and you chose to slice perpendicular to the axis. That means you're going to use delta y. That means pi r squared times r squared minus r squared times h. That tells you that you had to go in and label 2 r's. And then you also always have to go in and label where x and y are sitting. So in this case, notice that this little r from the axis of rotation to the near end of the slice is just sitting on the y-axis, and the axis of rotation is always at -2. So little r is equal to 2. So the little r is the constant 2 here. The big R is the one that's variable and dependent upon the function. The big R not only covers the distance from the parabola to the y-axis, but also from the y-axis to the axis of rotation. So big R is equal to x plus 2. If you're worried that I wrote x plus 2 and the axis is sitting at -2, it's because we're trying to find a distance and we wrote x minus a -2, which is x plus 2. We're trying to find a distance, so we're subtracting the 2 left from the right. Our height is going to be delta y. And that means this is no good. I can't have x plus 2. I have to trade my x for y. So if y is x squared, x is the square root of y. And in this case, I can see that I want the positive square root of x. Positive and a negative square root of x that correspond to that y, but I didn't even draw the negative side. That's not part of my rotating plan. Questions? What did we do? What? X is incompatible with my delta. Once we decide on the delta variable as delta y, everything has to be in terms of y. So the volume of the slice is going to be pi times big R squared, which is square root of y plus 2 squared, minus little r squared, 2 squared, times h, which is delta y. I forgot to switch to the light blue for the square root of y plus 2 into 2. Oh well. I was distracted by the fact that I once again wrote square root of y plus 2. That's a terrible way to write that. I should be writing 2 plus square root of y. I know better. It's the time change. Messing things up. The reason you don't want, it would be preferable to write 2 plus the square root of y. If you get a little bit too exuberant with your square root symbol, it like drags the plus 2 into it. And saying, well, why are you doing the square root of y plus 2? It should be the square root of y plus 2. I know it sounds like I said the same thing, but it was totally different. This is why English is a terrible language for trying to communicate math, but you know, what are we going to do? All spoken languages are terrible at communicating math. It's inconvenient because the radical acts as a grouping symbol as well. So now we just have to integrate over all the y values where we have a slice. Should probably clean this up a little bit too, but since we're just going to be plugging it into our calculating machine, we're not going to worry too much about it. Although I always factor out my constant pi. I'm not going to simplify this. I'm going to write 2 plus root y for safety. And then I'm going to simplify the 2 squared as 4. I'm going to make sure my delta y becomes a continuous dy. Then I just have to go back and see what my y values are. The y starts off here at 0 and ends at 9. Region and axis are given. Slice parallel, perpendicular is your choice. Once you make that choice, everything else is fixed in place. That's your decision, but then that's you deciding to use this particular volume of the slice. Great thing about solids of revolution, it's never just one problem. We can always test our other slicing strategy. So region given. Axis is also given. Region and axis, those are given things. In the previous example, or in the previous calculation, we chose to slice perpendicular to the axis. So now we're going to make the other choice. We're going to slice parallel. It's because after we slice perpendicular, We punched in our answer and we got an achievement, a little notification. Achievement unlocked. Slicing perpendicular. And then we thought, oh no. That means there's an achievement for slicing parallel. And the game's like, oh yeah. We're trying to increase replay value. And we're going to play on your addiction to do it. You played the game good guy style, now go play the game bad guy style. You have to do the whole thing over. Compelled not by your fascination with the story, but you want that little digital trophy, don't you? And then you're like, oh, nah, I don't need it. And the game's like, oh, but you want it. 100% completion. Oh, no, I'm not going to do it. 100% completion, fading away. And then you go play the game again. You didn't even like the game that much. But there was an achievement. And if you speed run it, it's only going to take what, 8, 9, 10 hours to finish the game. So we made a choice. Now we're slicing parallel to the axis of rotation. That means we have chosen the volume of the slice. So we write 2 pi times the radius times the height times the delta variable, which is delta x in this case. I'm going to need to write r and h in terms of the delta variable, which is x. So I'm going to need to go to my diagram, label what r is, and label what h is. The radius, anything that we call a radius, will be measured from the axis of rotation to the slice. Then the height in a shell's calculation is just the dimension of the slice perpendicular to the radius. We've got to write r and h in terms of x and y. So we need to know where x and y are. Now we can see that the big R in this calculation is the same as the big R in the previous calculation. Big R is going to be x plus 2. Get from the parabola to the axis. We start at the parabola and we start at the right side, subtract the left side. X minus a negative 2 is x plus 2. In the previous problem, I needed to write that in terms of delta y. We don't need to do that here. I want x. The variable, that wasn't a request for illicit substances. I want r in terms of x. In the previous problem, it was delta y, so I needed to change it. In this problem, it's a delta x. I leave it as x plus 2. My height is from the parabola up to the y equals 9. The y is down here from the x-axis to the parabola. So if the whole thing is 9 and one piece is y, the other piece is 9 minus y. But this we cannot use. I don't want 9 minus y. This is a delta x integral. But fortunately, right up at the top, y is equal to x squared. So I'm going to rewrite my height as 9 minus y squared, x squared. So the volume of the slice is 2 pi times x plus 2 times 9 minus x squared times delta x. So now when we go to write the total volume, I'm going to factor out the 2 pi. And we're going to integrate x plus 2 times 9 minus x squared. I suppose that we could multiply that out, but we know that we're just going to be punching this into a calculating machine. So let's just punch that in. Let's not put any more algebra between us and what we want. So now we've got to integrate over all the values of x that we have a slice. So the region is not present from -2 up to the y-axis. So I'm not going to start at the axis just because it's the axis. The values of x over which we integrate are determined by the region. And the region starts when x is equal to 0 and ends when x is equal to 3. I didn't pick 3. That's where y squared and, or x squared and 9 meet. And we just hope that these are the same. Cool. So much faster on the second one. I did this one off camera, but look how long that one took to calculate. So in this one, the calculator definitely is like, oh no, slicing parallel is better for this one. Probably the square root. So in both cases, we got 353.43. We suspect it to be a multiple of pi, so it's 112.5 pi. I wonder. Oh, I could have just dropped the pi. So it's having to hold on to a little bit more for that perpendicular calculation. But they came out the same. It is super unlikely that we did these both wrong in such a way that they both came out to the same answer. That's just not going to happen. This is us being, it's like, yeah, this has got to be the right number. Any questions? All right, that's going to do it for today. I will see you all on tomorrow. Everybody have a good day, and thanks for playing.